We now want to analyze functions using derivative. Assume that the function is continuous. If the derivative is larger than or equal to 0 for all x in an interval, then f of x is increasing. And if the derivative is less than or equal to 0 for all x in an interval, then the function is decreasing. And if the second derivative is larger than or equal to 0 for all x in an interval, then the function is convex. And if the second derivative is less than or equal to 0 for all x in an interval, then f of x is concave. If the function is increasing, then it's quite obvious that the slope is positive. For if we draw a tangent to this one, we see that the slope is positive for an increasing function. And for a decreasing function, the tangent is instead negative. So that corresponds to the two first sentences in the theorem. And for a convex function, we have that the tangent first have a negative slope, goes to 0 and then to a positive slope. So the tangent's slope is increasing. And the slope of the tangent is given by the derivative. And if that is increasing, that means that this function is increasing. That means its derivative is greater than or equal to 0. And that means that the second derivative is larger than or equal to 0. For a concave function, one sees that the slope of the tangent goes from a positive value to 0 to negative. So this means that the slope is decreasing. And the slope is given by the derivative. So if that is decreasing, that means that its derivative is negative, which means that the second derivative is negative. And this motivates the two last rows here. And thereby we have intuitively motivated this theorem here. We now want to find the maximum and minimum of a function. To find a maximum or minimum, we have to look among the local maximums and local minimums. For a function to have a local minimum, it must look something like this, and the local minimum is here. And for a function to have a local maximum, it should look something like this, and we have the local maximum here. In either case, we see that the slope of the curve in the point where we have the local minimum or local maximum, the slope is 0, which means that the derivative is 0 in those points. So if you want to find local minimums and local maximums, you should look for points where the derivative is equal to 0. However, finding a point where the derivative is 0 doesn't guarantee you that there is a local minimum or maximum, for it could also be a saddle point, like this. So here the derivative is 0, but still it's not a local minimum or a local maximum, but a saddle point. And we could also have a saddle point of this type. So if we find a point where the derivative is 0, we have to investigate further if it's a local minimum, local maximum, or saddle point. We can also have a curve with a spike. And in the spike here, for example, we see that it has a local maximum. But in that point, the derivative is not defined. If you look at the slope of the curve just to the left of this point, it is positive. And if you look at the slope just to the right of this point, it is negative. So in this case, there is not defined a tangent in this point, so there is no derivative. But still there is a local maximum. And the same would happen, for example, if we have a point like this. We could also have a situation like this, where the graph is not defined for some points. For example, here it's not defined for this point where we have a vertical asymptote. So if you look for maximums here, you will see that it has no maximum, since it goes to infinity on both sides here of the point where the asymptote is. In this point, the derivative is not defined. So again, here we have a point where the derivative is not defined that you also have to investigate. Then you can also have a situation like this. And here you see you have a local minimum and here you have a local maximum. But the global maximum occurs here. And this point, the derivative is not 0, but this is an endpoint of the curve. This is also an endpoint of the curve, but this endpoint does not belong to the curve. So in this case we have a global maximum occurring at the endpoint, but we don't have any global minimum, because we can get as close as we like to the endpoint, but you can never go to the endpoint. So there is no point that is the lowest of this curve, so there is no global minimum. So you see that if we want to find maximum and minimum of a function, we need to look for points where the derivative is 0. We also look for points where the derivative is not defined, like point 0 for example, and like here. And we also have to look for endpoints. And these 3 types of points are called critical points. That's point we have to investigate if we want to find the maximum and minimum of a function. So first of all, we have to look at endpoints. We have to look at points where the derivative is 0. And we have to look at points where the derivative is undefined. So if it has maximum minimum, it happens in one of these 3 points.